Okay, so guys, this is question number 5, and I accidentally include this 3D problem in our first SI worksheet. This supposed to be in our second SI worksheet because he might not cover much of what 3D problems are in the class. But since I already put it right here, I think I'm just gonna work this out and show you guys so you guys can get familiar with what type of 3D problem he's gonna put in the quiz and exams. So let's just begin to work this problem. So question number 5 says determine the magnitude and coordinate direction angle of the resultant force and sketch this vector on the coordinate system. So I want you guys to know that the coordinate direction angle that's simply just f equal to f cosine of alpha I hat plus f cosine of beta j hat plus f cosine of gamma k hat. That's it, simple as that. And I want you guys to know that each of these angle, alpha, beta, and gamma, is on its positive axes. So this is positive x-axis, positive y-axis, positive z-axis. And for positive, I mean that it's counterclockwise. You guys will know, you guys will get this as I work the problem. Right now, it might seem a little bit tricky or weird, but you guys will understand as I work this problem. Okay, so first step, let's begin to work this F1. Put this F1 in the coordinate direction angle form. So F1 equal to its force 400 newtons cosine of its alpha, which is going to be this 45 degree. And you guys can see that right here is measured from the counterclockwise direction. Because in this class, counterclockwise always means positive. Clockwise always means negative. And when you guys do the coordinate direction angle form, always do them in the positive form. So which means that this right here shouldn't have any negative numbers. Okay, so F1 that's equals to 400 cosine of its alpha, so 45 degree, plus 400 cosine of its beta. Its beta is going to be the 60 degree right here. Oh, my bad. Right here, 60 degree to its y-axis. And plus 400 cosine of this gamma. Gamma is not given right here, but since we know that this z-axis is 180 degree, right? And we know that this is right here is 60 degree. And if we want to measure this angle to its z-axis, simply just take 180 minus 60. We're going to get 120. This degree right here, 120. So cosine of 120. And then we can actually put in the calculator and write them out. Sec 1. Oh, I forgot my I hat, J hat, and K hat. So if I put in the calculator 400 cosine of 45, that's equals 282.84 I hat plus 400 cosine of 60 plus 200 J hat 400 cosine of 120. That's negative 200. See, if I put in a calculator like 400 cosine of 120, it gives me a negative value. But first of all, I have to keep its sign right here positive, because when you put in the calculator, it would give you like either positive or negative. So first you have to, in the coordinate direction angle, you have to keep all the signs in positive form. That's okay. Okay, so right now let's work F2. This is F1. F2, I'm putting in the different color for you guys to see. So F2 is a little bit tricky. First, we can begin to find out what F2Z is. We know that ZX is right here. This is F2Z. But we can, by the law of parallelogram law, we know that this could be F2Z too. So F2Z can be right here. So that way we have more stuff, more information we know to solve. So F2Z, that's simply just equal to force right here, 125, 3/5. And then if we put this in the calculator, we're going to get this is equal to 75 newtons. And then right now we have to find F2 prime. Okay, so here's where what gets tricky. I want you guys to know, in the 3D problem like this, F2 prime is always this one. It's always this. If you guys know that, that's crucial. That's an easiest way for you guys to work out a 3D problem. F2 prime is always here, or any kind of prime forces is always this one. Because F2 prime is what is being reflected by this F2 force. Because F2 it has because F2 is X, Y, and Z components, and from the information given, we can't really find out what all these three forces. So that's why we have F2 prime right here. So F2 prime is fairly easy. So if we know that F2 Z is 123/5, then F2 prime is simply F2 125/5. But you have to break F2 into its F2x and F2. You have to break F2 prime into its F2x, F2 prime x, and F2 prime y. So I have to break it into F2 prime x and F2 prime y. This is F2 prime y, F2 prime x. Let me just draw the triangle. F2 prime y, F2 prime x. And this is 20 degree right here. This is F2 prime. Since we already know F2 prime is 125 times 4/5, if we put this in the calculator, we get 100. So F2 prime is 100. So F2 prime is simply 100 cosine of 20 because it's adjacent to this 20 degree angle. If we put this in calculator, we're going to get 93.97 I hat. And F2 prime y, that's simply 100. Ooh, negative 100 because it's in the opposite direction from the positive y-axis. Sine of 20, that's equals to negative 34.2 j hat. Okay, so right now we have our F1 in the coordinate direction angle form. We have to put our F2 in the coordinate direction angle form also. So F2 is equal to, if we put in the coordinate direction angle form for x, y, and z, then we can put in 93.97 I hat plus negative 34.2 j hat plus the 75 degree, 75 newton right here, just 3. And then right now we have to find where our FR is. So FR simply just F1 plus F2. So right now you have to add out all of the X component, Y component, and Z component. Okay. So let's break FR into FRX. That's simply just 282.84 plus 93.97 that's going to equal to 376.81. I hat FRY, that's simply just 200 minus 34.2. That's going to be equal to 165.8. J hat FRZ, simply just negative 200 plus 75. That's going to be equal to negative 125. K hat. And right now we have those three. So if we put in the FR form, that's going to equal to, put in different color. That's going to be equal to 376.81 I hat plus 165.8 J hat plus negative minus 125 K hat. And then to find out the magnitude, simply just square of them and take a square root of that. So 376.81 square plus 165.8 square plus negative 125 square, and the result you're going to get is 430.23 newtons. Okay, so this is the answer to the magnitude of the resulting force. But we also have to find the direction of the coordinate direction angle. So I have to find direction. I don't have enough space, but I think I can fit in right here. Box right here. So direction. Because we have to find the direction of what the alpha is, what the beta is, and what the gamma is. So it's very simple. So alpha is just going to be equal to cosine inverse of FRX over FRY. Oh, not FRY. FRX over FR, because alpha, that's from the positive x-axis. And beta, that's cosine inverse of FRY over FR. And gamma, that's equal to cosine inverse of FRZ over FR. And if we work this out, we know that FRX that's equal to 376.81 over is FR for 30.23, and we're gonna get 28.86 degree. And for beta, we're gonna get 165.8 over 430.23. That's going to be equal to 67.33. And lastly, negative 125 over 430. And we're going to get 106.89. Okay, guys, so that's all. This is the answer to this question. I know that like 3D problem is a little bit complicated and is usually pretty long to solve, but like at least when you guys understand the steps, like what the methods to approach this problem, it becomes very simple. And guys, in the exam or in the quiz, please read the question carefully to see what is asking. Okay, so that's all for this exercise session, and I'll see you guys in the next exercise session.